Welcome everyone. Welcome to the second live stream from JavaOne on the second day of JavaOne. I wish we could show you more of the conference, but we got this amazing studio. But next time maybe we can shoot more somewhere down there and show you the more of the sessions live, or maybe even show you how awesome like the food and all the other stuff is. Can I say I'm positively surprised by how good the food is? Probably I shouldn't, but I am, because usually it isn't at conferences. Or not usually, but sometimes it isn't. Anyway, more things that I made mistakes on. I promised you Gavin Bierman to talk about Project Amber, but it turns out he's in the UK, and that somehow there was like a miscommunication there where I didn't express like, no, in person in the studio. I got no one else than Brian Goetz for you, though. Assuming the audience knows you, so we just skip the introductions. He knows all the things about all the things on Java. Right, and we want to talk about the Project Amber update, like what's going on with Amber and where is it moving. But since you're here, we can maybe towards the tail end also talk a little bit about other things that are going on. But yeah, let's start with Amber. And you gave a talk about that and the other language evolutions yesterday. Maybe give us a little bit of an insight.
Yeah. So Project Amber is kind of unusual among the OpenJDK projects. So there's a lot of projects going on: Loom, Valhalla, Babylon, etc. And most of the other projects have a single focus, right? Loom is about virtual threads and structured concurrency, and Leiden is about startup and warm up, and Amber is like all over the map, right? And most projects deliver a small number of coordinated JEPs. Amber is like this JEP cannon that fires off JEPs every 6 to 12 months, sometimes multiple JEPs in the same, in the same release. And so it's kind of a different beast. And the tagline that we gave it when we started Project Amber was that it was about right-sizing language ceremony, which is to say the language features that are smaller than big things like generics and lambdas and what have you. And this sort of coincided with our switch from the doing releases every 3 years to doing releases every 6 months. And so it was kind of a forcing function to learn to take medium-sized features and break them down into a bunch of smaller features. And this works really well, and it allows us to deliver things faster, and it allows us to deliver things that are individually simpler so that people can sort of wrap their heads around it easily and see the value in it. But it's kind of a double-edged sword, because it means that we don't ever get a big thing like generics or lambdas, and we probably never will again, not because we're not doing big things, it's that we're taking big things and we're slicing them up into a bunch of smaller things and delivering them over time. So, in the talk that I did yesterday.
So briefly,
go ahead.
On the double-edged sword, I was wondering, is it also a certain risk that you're cutting things and then you have to, because then you have to make decisions sooner, right? If you would make it all in a big lump, you can say, okay, we're basically done on this feature, but we'll wait until we're done on all the features, and then we see perfectly how they fit together. So has that been a problem or a concern? Or surely a concern.
It's an omnipresent concern and risk. We have done extremely well, avoiding that risk, in part because we don't just design the first little bit of it and ship it. We may be designing 2, 3, 4 steps ahead, and then we say, okay, we see how all the pieces fit together. We see where we're going in the long term. And now let's identify a natural bit to sort of carve off, specify, deliver, and have it live on its own. And so, if you sort of follow the history of, for example, pattern matching, which has been a big theme in Project Amber, a lot of the original design documents that we wrote were 5, 6 years ago at this point. And
they're still informative. There's still stuff in there that we don't see yet in the language.
And those documents, address not only things that we delivered 3 years ago and 2 years ago and last year, but things that we're still yet to deliver. And so just because we're delivering in smaller increments doesn't mean we're designing in smaller increments. And what it's taught us is, when you look at the releases from Java 8 and back, 8.7.6, et cetera, we had these big release drivers, these big problems to solve, and we've made unrealistic projections about when we would be done, and of course, so the last part of it was always painful. But also, when we finished working on something like Lambda, we didn't really have a clear picture of what comes next. because we had delivered everything we had been working on. And so there's not only like a pipeline stall when that happens, but also since we haven't been thinking about how does what we work on today connect with what we're going to do tomorrow, there were often discontinuities between the efforts. Whereas now we're co-designing a lot of pieces. So we're able to see what the interactions are, and there's much more of a continuity between the JEPs we do today and the JEPs we do tomorrow, even if they're not directly related on the same feature. And so that's something I think that we've been learning how to do, not only to carve things into smaller, more manageable chunks, but to sort of see what the connections are with other things that we may want to deliver in 2 years, 3 years, identify what the risk, the interaction risk is, and maybe not fully design the second piece, but address all of the aspects of it that might have interaction risk.
Well, that's interesting. So he's basically saying, I mean, yes, there's this risk that you misdesign something early, and then, but also that in another sense, that risk is less because instead of having like the big lambda thing, and when you're done, and you search for the next thing. Now that you have this continuous drive, you make it more likely that you're always thinking about the next thing. That you don't just develop lambdas and think only until that release, but you will always think about the features coming up after that. Okay, yeah. So then, but Amber does as you describe, but also there's some arcs, right? There's some things that are like larger stories within this. What you describe it as a canon of
a JEP canon. Yes.
JEP canon. Yes.
Yeah. So so some of the JEPs that have come out of Amber, like text blocks or local variable type inference, are truly standalone. We delivered them, they're done, we move on. But a lot of the things we deliver in Amber are part of a larger feature arc, like records and sealed types and pattern matching, which sort of all go together, or source launcher, compact source files, all of the on-ramp stuff, sort of the module imports, those all go together as well. And, like I said, that's worked out really well because things like records are useful by themselves, and they also work great with pattern matching. And so we're able to deliver something useful now, and it interacts positively with, with something else later. But one of the challenges, there's always a drawback of everything, right? Well, one of the challenges is it's hard. It's, sometimes when we're explaining, well, here's what we're going to do in this JEP, and people want to, and they naturally want to judge it based on what's on the paper right in front of them.
Yeah.
And not in the, well, like, where are you going?
Yeah.
And so that, they'll say, oh, well, shouldn't it be this way? It's like, well, you might think it should be that way, but 7 JEPs from now, we're going to want to do this. And this is part of a larger thing. And it makes it harder for people to see the big picture, right? Like when we did generics in Java 5, there was a big picture there, and, there was a lot to absorb, but it all, fit together. And now the big picture is like partially in the present, partially in the future. So that's a little bit of a challenge to manage. But I think overall, it's been a really good transition.
It makes also, well, I mean, for us in DevRel, the 6-month release cadence, of course, is good because it means there's always something to talk about. But what you described there is also true. Like sometimes people look at the list of a specific release, and it's like, wow, like JDK 24 is a good example. If you're like a language nerd like I am, you look at 24 and it's like, well, it's a couple of previews, nothing much there. So because all the big changes get cut up in small pieces, it's also easier to think, oh, nothing. I mean, there's constant movement, but there's not much happening. There's never like the big thing. Probably JEP 401 Valhalla, which we get to later, is probably closest to that. But most of the other things are like, oh, well, great, now I can use the underscore. How big deal, big whoop. But it fits into something larger that people should use then,
But even like, JEP 401 and Valhalla is a good example, right? JEP 401 represents what is the smallest piece of Valhalla that we can ship, on its own. And so there's going to be some people who are like all excited, yay, Valhalla's finally shipping. And then there's going to be the naysayers out there, of which there are a few, who are going to say, oh, but they didn't do the null restriction. Oh, but they didn't do generic specialization. Oh, but they didn't do operator overloading. And that's true because we didn't want to wait until we did all of those things to ship anything, right? And so we're constantly trying to say, to look at a JEP and say, is there some way that we can carve this up into a smaller piece that still has an organic, wholeness to it?
Yeah. So on the topic of like different arcs within Amber, you said that there's like a little bit of random miscellaneous features like the text blocks and var that you mentioned. And then you mentioned 2 explicit stories, which is the on-ramp and pattern matching.
Yeah.
And at least on pattern matching, my impression is that like the main arc is slowly coming to an end. Basically, we know pattern matching kind of does its thing, and now we'll slowly see where else we can use patterns. And we heard that there's deconstruction, which probably, maybe I'm giving myself the answer. I was going to ask, what's other big arcs coming?
Yeah.
And I'm wondering, is deconstruction already its own arc? Because I know there's a lot of work going in that, right?
Yeah, I think so. I think we're coming to the end of sort of the data-oriented programming arc, which is, you know, record seal types and simple pattern matching, type patterns and record patterns, et cetera. And you know, that's a really useful, you know, thing unto itself. But there's kind of another arc coming that also leans on pattern matching, which is being able to create your own patterns. And basically any code you write that is conditional, where, you know, you look to see if some object is in some state, and if so, you extract something interesting from it. That is logically a pattern, but we've always had to write that in a way that made it not as obvious that it's a pattern. And so, you know, the next big arc is bringing patterns into the programming model itself, into the object model itself, where a constructor, you know, captures how I take, you know, an object's ingredients and turn them into an object. And then you have the reverse of that process of taking the object and breaking it down into not necessarily the exact ingredients that, you know, you were handed as a constructor, but ingredients that would be suitable for recreating this object. And the reason that's important is that there are a lot of mechanisms, both in the language and frameworks, for taking things apart and putting them back together. Serialization is an example of that. Withers is an example of that.
Yeah.
You know, where you have an immutable object and it has 17 fields, and you want to like keep 16 of them but change one of them. Well, you want to take it apart, make one small little change, and say, now put it back together. And in order to make things like that not horrible and messy and ad hoc, you have to have a mechanism for taking things apart that is sort of at the same level of abstraction and provenance as constructors are in the language model.
But that also means that this taking apart really, I mean, we're getting way ahead of this, right? I'm thinking about what would be a good way to use this feature, describe this feature, but you're really describing it as the inverse, basically, of the constructor, right? Yeah. So it's not, I probably shouldn't think like, oh, well, this use case could be niftily expressed in a pattern. I'll just write a pattern that just returns something. You said it should at least resemble the constituent components of this instance. It should just be random content. Or so I'm wondering, like, what about we talked about this way back, I think, about a map and a key that contains. So a map contains a key. Will I be able to write a pattern that says, well, if the key matches, here's the value? So I don't have to do the if map contains, then map get.
Yes. So map.get is a particularly problematic method, right?
Yeah.
You know, so you know, the way it was written, you know, in Java 1.2 is that it's a method.
It feels like you're pointing to the past, like it's those guys.
But that was, we had the tools that we had at the time. You know, there's this, you know, magic value null that is a universal sentinel, and we return that if we can't find it. And like, well, that's horrible because you know, what if your map contains null as a value, right? How do you tell the difference between there was no mapping present, you know, or there was a mapping to null? And some map implementations don't support null as values, and some do. And you know, well, you could ask contains key. But like, what if the map is a concurrent map, and like, you know, some other thread might be putting values in it between the time you ask, does it contain the key, and like, okay, get me the key, right? So map.get, it was a significant compromise. Since then, the language has evolved quite a lot, and there are a number of other ways we could have chosen to write map.get. I'm not going to say one is better than the other, but it could have been something that returns an optional.
Yeah.
It could have been something that takes a lambda.
Oh, that specific example, if the map can still contain nulls, the optional is still kind of misleading, right? Because if the map can contain a null, you would still have to return the empty option, and then the empty optional still doesn't tell you whether it was null or not.
Yeah, that's
true. Should have written an option that can contain null. I shiver when I think about it. Yes.
And you know, and soon we'll have nullity control in the language, and so we'll have more tools, and you know, at that point it becomes reasonable to say, well, would we have written it differently? We can't go back and change the past, right?
Yeah.
But you know, would we have written differently? And you know, patterns are another tool that we have to express conditionality in APIs.
Okay, but then I wonder, should a deconstruction pattern should deconstruct again the map probably somehow? Maybe a map just shouldn't have a deconstruction pattern. But if it would, it should deconstruct into like all the keys and all the values, right? Because you said deconstruction should really really reflect the whole state of the thing and not just like a little slice of it.
Yeah. So deconstruction patterns, not to get too far ahead of ourselves, but deconstruction patterns are
too late, I think.
You can think of them as the inverse of constructor. Well, we have other named blobs of code in classes. We have static methods and instance methods, and they might reasonably have an inverse as well.
Okay.
So we have map.put, which is a way to put an element, into a map, talking about one element. So you could imagine a pattern, not a deconstruction pattern, but an instance pattern that would express, a conditional query about the map that might be able to focus on a single element as opposed to the whole map at a time.
Okay, so that's what Amber is going next. On-ramp is still going on, and then also now that the main pattern matching arc is done, it's about custom patterns deconstruction, or rather the other way around, right? First deconstruction, then custom patterns. Okay, is there anything else that you can? I know you have like these heap of notebooks. Surely there's something in there that you're also thinking about. But if you can't share it, I understand. But is there something?
Well, so there's a sort of wave of stuff that's coming from Valhalla that's going to affect sort of every corner of the language, which is null restriction.
Okay.
Right. So null restriction, is a feature that some programs are familiar with from other languages like C# or Scala or Kotlin, where you're able to say this variable contains a string but not null. This variable contains a string and deliberately includes null. It's not an accident if it's null. And that's a way to be more explicit about the value set of a variable, and that's useful, and that's something that people have been asking for a long time. It also turns out to be something that is essential for Valhalla, both from a performance perspective of being able to give flatter and denser memory layouts, but also because of initialization. And we need a way to talk about, to be able to talk about this variable can't be null and it's provably initialized before anybody can observe it. And so that provided sort of the final impetus to address the nullity problem, which is challenging and has some surprising consequences, but that's going to ripple through everything else, right? It's going to ripple into pattern matching, for example, because if you have a type pattern string S, well, if you're able to denote the type non-nullable string, then you have to define the semantics for what is a non-nullable type pattern or explicitly nullable type pattern. And so there's a whole wave of threading these things through pattern matching, bounds conformance, type inference, all of these, overload selection, all these different corners of the language. And I suspect that that's going to consume our JLS update bandwidth for a while.
Okay. So that also means, in the spirit of things coming somewhat in slices, and so that people who observe that shouldn't get ahead of themselves and see one slice and say, oh, well, that's not all I wanted. Does that also mean that even if we get null restricted types, that they might not immediately work everywhere, but that there might be a phase where, we get the feature now and it works like in 80% of the places, but patterns, for example, need to be updated in the coming releases?
So that's a hard one, because we on the one hand, we'd like to sort of carve things up into sort of minimal deliverables. We also want them to be clean. The kind of the rubric that we apply about could this be a standalone JEP is, if this were the last JEP ever, would we leave the language in a clean state?
So the answer then would be really no for what I just proposed.
Right, because that would be leaving something in a half-done state. And so that's probably going to be a fairly large JEP. Even if its syntactic intrusion into the language is small, its intrusion into the spec will have something in each of the 18 chapters of the JLS.
Okay, that sounds like fun.
Yeah. Well, yes. That's what we do.
Okay, we got about 1 more minute left. You just briefly mentioned Valhalla, and in that talk yesterday, you also, towards the end, gave a little bit of a roadmap, which I should say doesn't contain any timeline, doesn't have any dates. But I still found it interesting that you now have a better, or you're sharing now a better picture of what order are things going to happen. Because there were a couple of JEPs flying around. There's JEP 401, which is just value types, and then what did 402 do again?
Well, so the funny thing is 402 isn't the next one after 401.
Exactly, that's what I'm asking.
We thought it was at the time we wrote it.
Exactly.
And then over time, our perspective evolved, and that's actually kind of like fourth in the current lineup. So the two in between have to do with null restricted types purely from the language perspective, and then with the interaction between null restricted types and value types, which enables greater flattening, of object graphs.
Okay, so the current thought process is JEP 401 will introduce value types.
Yep.
Then this unnamed JEP will introduce null restricted types.
Right.
Funny that Valhalla took on another big project, by the way.
Yeah.
And then the next unnamed one will not have any language exposure, but just change how these interact.
You can think of it as like a multiple inheritance thing, where like you have value types is independent, null restriction is independent, and then they sort of have a child, which is null restricted value types.
Yeah, but those are so we're saying that's just like that's more like on the JVM side, so it flattens and denses more. Okay, and then after that we get maybe JEP 402.
JEP 402 is kind of a loose end cleanup where it has to do with taking the primitive type int and the null restricted value type integer bang, and minimizing the gaps between those two types, because morally they should be the same type.
Yeah.
Right. But and we can make 98% of them overlap, but there are some loose ends of currently we treat int and integer different in overload selection, for example, and we're not going to be able to change that. But but what we can do is align things like can I treat an array of int like an array of integer bang and vice versa?
Yeah.
And can I get array covariance between int array and object array?
Yeah. That's all very exciting. I'm gonna somehow stop myself, and I want to get like praise for the self-control to not ask you when, though, because I want to know. But okay, thank you very much for that insight.
Yeah.
I'm looking forward to seeing all that stuff. So I hope you go back and work on it right now.
Absolutely.
Thank you, Ryan.
Thanks a lot.
Good. And I'll have on Ron in a minute. We'll do a little bit of a changeover so you can enjoy the cool loop. Turn up the volume. The music is awesome. And I'll see you in a minute. Okay, welcome back. So we got Ron Pressler with us, and most people know you as Mr. Loom, but the guy who did Loom.
Yeah.
You sound like yes, but you're also doing other stuff. One of the big pushes is you're very invested into the on-ramp that Brian also just mentioned, which is a very interesting topic on its own, but we can't cover that today. What we're talking about today is another push that I think happened independently of you, but you like kind of coalesced into an idea, right? The idea of integrity.
Yeah, I volunteered to do some things that we thought might not be the most popular things. So.
Oh, that's why they did after Loom. So you're good guy Loom, and then you're bad guy integrity.
Yeah. I had some credit to burn. Yeah.
Okay. Yeah, because I thought, isn't that Mark's role to do the stuff that nobody likes?
Maybe, but he's busy with other things.
Yeah. Okay. Okay. So then let's talk about integrity by default. I think it's important there to make a point. Yes, it might feel to the users or to the Java developers as something that they might not like, but there's actually a big upsides there that are very important. So yeah, why don't you describe what the idea is about, and then we can talk a little bit about how it impacts Java's development currently.
Yeah. So first of all, thank you for having me. The way I presented in my talk, Brian likes to call certain features jetpacks, and other features are seatbelts, and everyone's happy with the jetpacks.
Yes.
I know ZGC, virtual threads, FFM, and all that. The seatbelts are sort of like safety features, but they're very important to be able to do other things. And the work on making the JDK have more integrity, and I'll speak in a moment what that means, started out around JDK 9, but it's been progressing, and soon we will want to have features that depend on it being in place. That's why it's important to start this work now.
Yeah, so let's cover those features a little later. Let's first tell us what integrity is and then why it's important.
So integrity is the ability to make certain guarantees that everyone can trust, and both people reading the code or writing the code, as well as the runtime itself. For example, in a C program, you should never access array outside of bounds, but it's not guaranteed. In order to know whether or not that happens, that is a desired property of a program, to never access array outside of bounds. But to know whether or not that's the case, you have to analyze the entire source code, including the dependency. In Java, that you can't access arrays out of bounds is guaranteed.
Yeah.
And so that property has integrity. The property that you don't access arrays out of bounds.
Right. So I think just to clarify, so in Java, if you have if you go beyond the array bounds, you get an exception.
You get an exception.
And in C, you just read potentially weird memory.
You don't know what happens. Anything can happen.
Exactly. So that's the point, right? So we're not saying that so the exception is good in that sense because it says you did something wrong and you don't get silent misbehavior.
Yeah, nothing happens other than, the exception stops you from doing anything. So that is integrity, but that property is enforced by the JVM itself. Although you can ask yourself, is it always true in Java? And that's all starts showing, the cracks start to show.
Okay.
For example, some people use the unsafe class. You can access an array out of bounds using unsafe.
Right. True. I was going to say how though, but right.
If you use JNI, you can access a Java array out of bounds. And that starts showing already some of the problems. But another question is, can Java code create its own invariants, its own desired properties that have integrity, that are guaranteed? And the answer is that in many situations, you want to be able to, and you almost do. The classic case is using encapsulation. So if you write a class and you want something to always be true about its internal values, like a number is always even, you make it private, and you only expose a constructor that makes sure it's true. You expose public methods that maintain that invariant. And as long as Java's access control has integrity, no one can mutate your field, your private field, without your permission. Then your bigger property has integrity. The problem is that access control doesn't have full integrity in Java. Again, there are features, deep reflection, that can undermine that. And the ability to trust invariants is important both for you as someone who writes the code and wants to make sure it works. It's especially important if what you're writing is some security mechanism. It's important for everything, but in security, it's easier for people to understand because you want your property to be robust. You want it to hold true no matter what other code in the program does. And in the old days, any piece of code in the program, including a fourth level dependency, you don't even know about it. Some library dependency decides that they don't like your invariants and they want to change it. Never mind why, we can talk about it later. But for some reason, if they want to, they can break all of your invariants. An example I like giving is strings. Are strings immutable in Java? Yes, unless some code decides to change them. They could through JNI, through deep reflection, through unsafe. And it's not just people who need to trust it, it's the Java runtime itself. If the Java runtime can't trust that strings are immutable, that final fields are immutable, then there are certain optimizations that it can't do. And that's where, and that is integrity.
Okay, so you mentioned the example you mentioned with the even and odd numbers, or with security relevant things. That sounds like almost too trivial to be important. But the reason for that is because or at least I think that the reason for that is that while those things hold to such a large degree that you basically, I think our perception as Java developers is that I can already 100% rely on those. So we already think that we can, even though technically we can't. And then occasionally something happens that shows that we can, and we consider that like a fluke situation that shouldn't happen. But the fact that it can happen is already the problem. And then in security spaces, specifically becomes, as you said, almost obvious why that could be a problem.
Yes. So there are two examples. Again, in a talk, I think maybe even others, but two examples I think worth mentioning. One is for the Java runtime itself, especially the JIT compiler, to perform certain optimizations. That something is true with high probability is not good enough. It has to be 100% certain. But even for code, especially security code, that you want to know is correct, there are situations, in fact, there have been security vulnerabilities that happen not because people want necessarily, we're only talking about benevolent code, well-intentioned code. There are bugs that allow a remote attacker to manipulate a good library that uses deep reflection to break certain important security invariants. But again, it's not, security is a good example, but it's true for anything that has to do with correctness, that you care about correctness, or performance optimizations by the runtime.
Yeah, and also as I said, like it could just be a bug, right? Like it doesn't have to be nefarious that something breaks in invariant. It can just be a bug in some code that does deep reflection and it does unintended effects.
Yes.
Okay, so now that was very academic, so to speak. So we talked a little bit about why that's important, and we also talked about how which specific mechanisms can undermine that. Did you enumerate? Because you said, for example,
No,
but
so,
I think you
okay.
pretty much enumerated them. Right?
There's deep reflection, so specifically the set accessible method. There's JNI.
Yeah.
There's unsafe.
We should FFM probably also, right? Like
I'll
really
get to it.
Okay.
So deep reflection, JNI. There's a difference between JNI and FFM because JNI is similar to deep reflection in the sense that it can access fields and call methods. With FFM, it's a little bit different.
Okay.
Agents. An agent can change any code to mean whatever it wants. And did I say? Yeah. So deep reflection, JNI, agents, and unsafe.
Yeah.
And then you have FFM. So FFM, the only risk there that it can't really change any Java invariants, but it could cause undefined behavior in general. And we'd like to have most Java programs be free of undefined behavior.
Okay. And on the, because you said this started like this move towards integrity started with modules, and that probably tackles the deep reflection part, right? Because modules basically said, okay, well, unless you allow it in the command line, deep reflection of JDK internals or generally of modules is a no-no. You cannot do this anymore.
Right. That started in JDK 16. Some people think it started in 9, but it was only turned on in 16.
Yeah, true. Good point. Yes.
So in JDK 16, it was turned on, and that was the beginning because it blocked deep reflection. But the other mechanisms remained.
Yeah. But the important part there is while deep reflection is disallowed, it's not disallowed entirely. It's disallowed by default. I can still like say like, no, I know better. So it's like reflecting over Java lang, which is risky, but I will allow that for reasons.
Right. So that brings me to, I think, one of the most important points. So I talked about what is integrity. Now I want to talk about what is integrity by default.
Yeah.
So many times people have, so when you write a piece of code, you want to maintain certain invariants, certain properties that are always true. But the users of your code, sometimes they have good reasons to violate them.
Yeah.
It could be maybe you stopped maintaining your library and they don't have your source code and they want to work around a bug. There are cases. They should be relatively extreme. There are situations where they're actually more common, like mocking libraries.
Yeah.
So if you mock things, you want to mess around with internals. So that's so for testing, there are some reasons for serialization, not very good ones, but unfortunately,
that's the thing, right? In a gigantic ecosystem as Java's, even rare cases happen in absolute numbers. That's pretty common. So.
Right. So what are we saying? We're not saying that these things are forbidden.
Yeah.
We're saying they're forbidden by default unless you allow them. Now, the question is, who is you? And you, and that's with everything, especially in security, but even in software engineering, the question is, who can do what? The person who can choose which integrity invariants to allow, selective breaking of, is the owner of the application.
Yeah. And
who is not allowed to do it? The libraries.
Yeah.
And the reason for that is that you can think about it in the abstract sense. You don't want any fourth-party dependency deciding for the library that it's going to mutate for the entire program that wants to mutate strings. But more concretely, the biggest problem, the biggest cause of the migration pains from JDK 8 to 9 plus was libraries, mostly low-level libraries, reaching into JDK internals that were not covered by Java's backward compatibility.
Yeah.
And then there's internal change and applications broke.
And they didn't know before.
And they didn't know.
Yeah.
Now, it's possible that those libraries had to do those things to offer certain functionality, but they made a trade-off. They made themselves non-portable, but they also made all of their consumer libraries consumer applications non-portable, and the applications didn't know that. They didn't know they were making the trade-off. So a fourth-level dependency just actually made your entire application non-portable. It couldn't upgrade the JDK. So integrity by default says a library can decide that it needs to do whatever it wants, but it has to inform the application and ask for its permission.
Yeah. So what we just, when we talked about the importance of integrity, that case that you just mentioned, actually, we didn't include that, but it's also an important part of integrity, because if you break the integrity, for example, by using internals of something, and then that those internals evolve as they're allowed to, then it doesn't, like, using those internals might not cause any problems on the JDK or library dependency version, whatever that you are on, but they might cause when you migrate and the internals change. And then because of this violation of integrity, you're now in a situation where you basically have to do extra work.
Right.
Yeah.
And this maybe that's a good point to mention. So one of the flags, one of the oldest flags used to break open the strong encapsulation, or for deep reflection, was add opens. And some people think that if they put add opens, that means they're working like in old mode and everything will continue working. That is not the case. The reason why programs broke between 8 and 9 plus and this encapsulation wasn't turned on then is because internals changed.
Yeah.
If you have add opens, it means that you have a risk you will break eventually.
Yeah.
So it's not, it just notifies you of risk and of an underlying problem that you need to solve. This is something that I need to fix. And the risk you're taking is, or made up, so it could be performance risk, it could be a security risk, and it could be a portability or maintenance risk.
Yeah. And
what integrity by default does says you can't hide those risks from the application. The application has to say, okay, in this configuration, I'm deciding willingly to accept those risks.
Yeah, because just to 100% clarify, because it is the application owner who takes on that risk. It's not the library. The library is not at risk because the library can say, well, if the internals change, I just release a new version. And for the library perspective, there's very little risk if it uses an internal API, for example, whereas it's the application owner that takes on that risk of having the application stuck. So that's why it's the application owner who should always be the person making the decision that, yes, I'm willing to take on this risk because I see the benefit. And it's also something that I have to admit that annoys me a little bit when some libraries say, oh yeah, just add opens all unnamed. I'm like, first of all, please be a module and please tell your audience or your users add opens just to my module. If you're using me on the module path, that should be the default. Add opens all unnamed should be like the next best. But also tell your audience why. What are the trade-offs? Why are you doing this? So that they can read. I'm a little bit worried that such low-level dependencies will train Java developers to just blindly accept those flags without really making the conscious decision that you just outlined. I'm taking on risk. Let me evaluate how likely this change is, because you say all of that will change eventually. But there's very many parts in the JDK that don't change a whole lot. So somebody could look into, like, do I expect change there? Or also, is it worth it for me? What do I get? And I'm a little bit worried that the ecosystem or the community starts to like evolve to just like, hey, I just add those flags. It'll be fine. And
well, it's not. It is a problem, and I agree with everything you said. But it might be a bit of a digression. But you said everything should be a module. I'll just say. People might not know this, but to make a jar into a module, all you have to do is put it on the module path. So instead of
but then it exports everything. So
it exports everything, but then your decision on which flag to do, add opens, or I didn't mention enable native access. That's for FFM and JNI. It's much more fine grained.
Yeah.
The problem with that is that currently you can't just take the class path, let's say using -cp, and drop the C, and everything will work. That is not the situation at the moment. But we might be changing that so that if you have a class path, you'll just be able to drop the C and turn the class path into a module path. I mean, the same as you can today, but to make it work transparently without having to add other flags like add modules. It's something we're considering. And that will make it easier for people to just move a jar from the class path to the module path.
Okay, that's interesting. We're close to being done, but let's briefly run through those examples that you gave. And just briefly though, what happens in JDK 24 or currently what's going on? What's the current state? So we talked about internals, about strong encapsulation, and that module system and modules in JDK 16 turned that knob, and now it's at opens or at exports. You have to add that.
Right.
So that seems to be settled.
Yes.
Then agents.
Right. So all the other mechanisms are right now at the stage where they just issue warnings, and they will remain that way. I don't know if all the maybe agents will turn into an error in 25. Not sure about that yet. But if you try to you can always add an agent on the command line because that shows intent. But loading it dynamically will issue a warning. As of JDK 23, There is now a warning if you use JNI, unless you pass the enable command, enable native access, same as for FFM.
You said 23. You mean 24?
No, I think it's 23.
Then 23 like
JET
this,
471.
okay, maybe you're right.
That's
the details.
for,
You will find
no,
the
sorry,
details
yeah, it could be. No, JNI is in 24. I think you're right.
Details, because the 23, sorry, the FFM used to be an error, and JNI used to be I don't care.
Right.
And now they're united under one flag that says, well, they're both a warning now. So actually, FFM got more relaxed, and in the future will get stricter again.
So we trying to make them the same. Yeah. So I think you're right about JNI JET 472. That might be in 24. So for JNI, you'll get a warning. For an unsafe, we're starting the removal process of most of its methods. I think that went in 23.
So deprecated for removal are a bunch of unsafes, memory access methods.
Yeah, I can't. In my mind, we're already in JDK 26, right? So we're at the end of 25.
Wait, why are you to what? We got 3 more months on 25.
Yes, but yeah, you know, that's we're getting our ducks in a row for 25. We're already thinking beyond.
Okay, so quick explain that. Why did I say we have 3 more months for 25? You would think, wait, isn't that 6 months away? Yes, but in 3 months, OpenJDK says, you're done. You didn't give me your feature. You have to wait for the next train. So that's why we're like a little bit time shifted. OpenJDK thinks that 6 months goes from January to June, roughly speaking, not from March to September.
Yeah, so I can't remember which feature went into which JDK version, but I know the current
Shame
state.
on you.
So the current state is you get the current state has a JDK 24. You get a warning for using most unsafe methods. You get a warning for JNI. JNI is a bit different because JNI is like FFM. You just have to add that flag. Unsafe is different because it's going away. Right. So it's not like add this flag and everything will work. You can suppress the warning, but you will have to take care of it.
Yeah, but I think the gist here is that ideally most applications have to do none or very little of that, because most applications do very few of those things. But if you do ever encounter documentation that tells you add this flag, add that flag, be aware that you're making a conscious decision. Potentially, I mean, it depends on the flag, right? But many of these flags, you make the explicit decision to take on risk, or rather, you make the decision, make it an explicit decision. Make sure that you know what's going on.
Yes, exactly.
Okay. Thank you for being here, Ron. Next time we meet, we're going to talk about more fun stuff, like the on-ramp, for example.
This is fun too. Actually, it lets us do many things.
Okay, it's fun too. We didn't talk about the downstream benefits, like optimizations, for example.
Optimizations, but primarily, we did mention it allows us to make big changes to JDK internals without breaking applications.
Yeah, at least without breaking the good ones. Okay, thank you very much. We're going to next have on, I think, Ana Maria and Paul Sandoz to talk a little bit more about, well, I'm not going to spoil it, another short break, and then we'll see you again. Have a good one.
Hello, folks. Welcome back to JavaOne live streams. And now we have a breakthrough moment. We're going to talk about Project Babylon here today with my colleague, Paul Sandoz. I'm Ana Maria Michalczano. I'm a Java developer advocate at Oracle in the Java team. And Paul here is...
Java architect in the Java platform group.
Well, Paul, yesterday keynote was impressive, was a little bit fast-paced on your demo side. So I thought that today, together with our audience, we're going to walk through the demo again. And I'm get some time to ask questions about the code you showed yesterday, because I'm sure that our folks watching live are curious on how that miracle of machine learning in Java works. How can they reproduce it? How can they try it at home? How can they enhance it? And I get to ask you a lot more about what Project Babylon is doing. So let's start first with what Project Babylon is aiming for, what is doing right now.
Right, so it's 2 things. The first is, we're working on 2 things. First is a feature called code reflection, which I described in the keynote. It's really a way to get access to code in a symbolic form that you can translate and interoperate with machine learning models like GPUs and Onyx that we're going to talk about. And the second thing is a library called Heterogeneous Accelerator Toolkit, developed and designed by Gary Frost. And it's a way to access GPUs using Java code.
Wow, that is indeed impressive. And since you brought up the keynote yesterday, can you summarize a bit what the demo was about? What do you aim to show there?
Right, yes. We got primarily 2 goals. We want to sort of show off the features that have been developed in the platform and are being developed in Babylon, and show that we can do this kind of thing.
That's nice.
And experiment with it. And also, importantly, we want to ensure and we want to evaluate that these features are fit for purpose for this kinds of use cases. And if they're not, why not? And we can learn and enhance them and fix them before they are placed into the platform for perpetuity and are fixed and we can't pull them out.
Well, in that case, I'm better for understanding concepts if I'm looking at the code. So
Same
how
here.
about let's look at
Let's
the
just
code.
have a conversation about it. Let's see how this goes. Okay.
Yep.
How much time do we have here?
I think we have
Enough time.
Yeah.
All right.
So what do we have here?
Let's, do you want me to run the demo first?
Yes, let's run the demo first, and let's explain to our folks how.
Yeah, it's a really simple demo that is a number prediction application. It's in presentation mode already. Do you want me to zoom in? I can zoom in like that. Is that good? Yeah. So we chose one of the simplest examples to explore first because we're still learning about this space. So we need to sort of, as I said in the keynote, sort of learn to crawl before we can walk and run. And so we're learning to crawl with this. And as we understand how to architect this system using features like Project Panama and Project Babylon, we'll get a better understanding of what the layers are. And then we'll build more substantial applications, hopefully, which are a bit more real world than this simple application. So the idea is you can draw a number in an image like this. And in an image, and then you can perform a prediction on it, and it gives you an output of the probabilities that the digit in this image is a particular number. So in this case, it guessed correctly the number 7. Yes.
So it would be like if I am to expand this demo, maybe in the future, it would be like a way to recognize handwritten text, maybe.
Yes.
And extract what actually was handwritten there.
Yes. Yes, that would be a way, yes. If you want to expand it out, it could be a sequence of digits that's a larger number, or it could be handwritten text, or it could be us speaking and translating the text. That's what machine learning models do. They make predictions. And so this is predicting from the digit in the image what the actual number is. And sometimes it can get it wrong, as I showed in the keynote. I'm dreadful at drawing 9s. Let's see. Nope, it thought it was a 7 still, but it thinks probability-wise 27% is actually a 9.
So the next best thing would have been exactly a 9.
Yeah, it gets it wrong. That's what machine learning models do. They're statistical machines. There's not a lot of there's a lot of cleverness in them, but fundamentally they're statistical machines.
Great. One question: the interface. What you used to build it?
Swing. Actually, I did not build this myself. A developer in the Java platform group called Adam Satona built it. I'd like to say thanks to him. And also Maurizio as well, the compiler architect, and also Adam Pocock from the Machine Learning Labs. They all helped build this.
That's amazing. It's a lot of people contributed to this result.
Yep.
Thank you. Now let's dig into a little bit more what's under the hood.
Yes.
And into the code.
Yeah, so what's going on here? So when I run the Swing application, we're actually instantiating this class called MNIST model. The reason why it's called MNIST is the MNIST has this classic data set of numeric digits and the numbers they correspond to, and that information is sort of available in the open domain, and it's a classic data set that people use to train models. So hence why it's based on the MNIST data model. Okay. And so this constructor here is called when we instantiate the Swing application.
And I see that you have given a few weights to...
Yes. So a machine learning model requires some constant data weights, which are effectively produced from training.
Got it. How did you train this?
We used a Python script. We used TorchScript to train it. It's actually in the code base if we want to see. So we're focusing on inference and not training right now. Again, we're learning to crawl first. I don't know whether we'll ever get to a training solution yet, but the Python script is here. And it's exactly the same machine learning model expressed in PyTorch. And it's used for training. And we extracted the weights out from this PyTorch model by exporting it to an Onyx model operating on it and extracting the weights out.
That's good to know. So now I understand how it works under the hood. Diving a little bit more in here, you mentioned that you use TensorFlow.
We don't use TensorFlow.
Oh, sorry.
Onyx.
Onyx.
Yes.
I saw Tensor in there.
Yes.
I just made me. So let's. I want to ask you a little more. The Tensor class is something that you created. It's part of the.
It's part of this prototype machine
machine
learning library
Okay.
that we've developed. Yes, Tensor is just it's a posh name for a multi-dimensional array. That's all it is.
Got it.
Nothing special.
Got it. And for working exactly with the Onyx runtime, what magic did you do?
Okay, shall we explain Onyx quickly?
Yes.
So Onyx stands for Open Neural Network Exchange, and it's two things. One is sort of way to represent machine learning models, and the other is a runtime to execute those models. And so you can think of it from the perspective of Java, a native runtime. And so we're going to interoperate with that runtime in two ways. One is to interoperate with its programming model, and the other is to interoperate with its runtime. And the first one will use code reflection, and the second will use Project Panama and bind to its C API and call the native functions in the Onyx runtime.
Okay.
So that's what we're doing. So every time I hit the prediction button,
it goes to classify.
It runs this classify method, which takes the image data as a float array, creates a tensor out of it. This will copy the on-heap data to off-heap data, wrapped around, and we call it tensor. And then we run in the Onyx runtime the machine learning model, which is encapsulated. My shift key is not working properly. Encapsulated in this lambda expression here. So that's our machine learning model.
Oh, wow.
Just here, this lambda expression. And this is what we translate to an Onyx model and then deploy in the Onyx runtime. There's a bunch of steps you can see here describe what's actually going on. But the main bulk of the work,
if we can see what
done
CNN
here.
has.
Yes, we annotate it with a code reflection annotation, which means we can access the code of this method at runtime as a Java code model. And then we can look at it and translate it to the Onyx code model in the required Onyx format. And we see a bunch of method calls here, like divide, a convolution. These are all Onyx operations.
Oh, wow.
Correspond to Onyx. We can see it takes as input here, the input image as a tensor. We get a scaled output here. This is a tensor as well if we replace it with the explicit type. We see a convolution takes a scaled input, but it also takes the weights here. We call them weights and biases for convolution, but they're effectively weights or constant data. I think people call them parameters as well in machine learning. So we see a convolution. We see it down here, familiar a generic matrix multiply, which takes weights and so forth. So it's fairly standard Java code, really.
That's what I was going to say. It looks very beautiful.
Thank you so much. I think it's still a little bit clunky. I think we can do better, but it's a start.
It feels beautiful in terms of the complexity is achieving, and the fact that you don't need to write some other intermediary code, and that code reflection, that annotation is so powerful. To further take this.
Yeah, it looks like ordinary Java code.
That's
the idea. Just like ordinary method calls. We translate this whole thing to an Onyx model under the covers. That's
amazing.
That's what's going on. Fairly simple. So this is doing a lot of heavy lifting. A lot of work going on.
I imagine. One more thing that I want to ask you. This project itself, to run it, you're using Babylon build, right? So
yes. Yes, that's a good point. Yes, I can actually, let's see.
Yeah, maybe show the code repo.
GitHub, OpenJDK, Babylon. Yeah. It's actually all in here. If the example I showed is available in the repo, first of all, you have to build the Babylon JDK. And here is the Onyx example. And you might be able to see in the resources coming in here. Where's our resources? I can't find it now. Oh, never mind. Main, or it's in the test area. We see resources where we have the PyTorch script I showed, and the MNIST weights we extracted out as resources here for our test code. So, excuse me, you can run this today and experiment with it. And we've only tried one on it. We only tried one machine learning example. If you try your own, it might fall over because, again, we're starting to crawl.
Yeah.
And as we build this out, we'll get more experience of how we can express more complicated and real world machine learning models in Onyx that we can execute.
Yeah, well, I watched the JVMLS talk last year in 2024, and folks, I invite you to watch the JVMLS talk that Paul gave in 2024. It's also talking about Babylon's progress, and there was a wish list that Paul had, and Onyx.
Yes.
And the Onyx runtime
That's right.
was one of the wish lists. But I'm sure if my memory doesn't fail me, there were more things on the wish list. So we are welcoming more people to evolve what is currently developed in Project Babylon. As you saw, is open sourced, is out there. You can try it. You can give feedback. Paul is looking forward, and all the other engineers are looking forward to getting some of that feedback from you. Now, if we still have a little time, I have another question about all this. During the keynote, you showed a very nice graphic of what's happening under the hood, because when you run the prediction, there's a lot of output in the runtime.
That's right.
And I think that the graphic you showed during the keynote, it was very, very nice to understand more than the output there.
Yes.
So what's the connection?
Yes, you don't really want to look at this output. These are the code models I referred to, but this is for debugging purposes.
Yes.
As such, it's showing what the code models are in memory and serializing out into text. But what we do to prove this is working, before we deploy the Onyx model we generated or generated from Java code, we write it out to disk.
Yeah.
And so we can actually look at it independently of the deployment to Onyx runtime. And so we can use an application called Netron that can load the Onyx model like so. And because Onyx is an interoperable format, Netron knows how to consume Onyx models. And we can see the equivalent description of the Onyx code.
Everything that happens in CNN, actually.
Exactly.
It's visually represented.
So we see
here.
the call to div, the conv, and then the weights it uses here on the convolution. We see the gem and the weights and so forth. So it's like a depiction of the Java code, which is not unsurprising, really, because that's what happens. We translate the calls in Java to Onyx operations.
Amazing.
And so, yep. That's the advantage of Onyx, not just that we can sort of leverage existing native tool chains and get up to speed faster on machine learning technologies. We can it acts as an interoperation point to other tooling out there for Onyx.
That's really impressive. Now, one of the things that probably some folks are imagining right now is, and thinking right now, because also you mentioned Gary earlier.
Yep.
How is HAT coming over all this? And so we talk about code reflection. What is HAT bringing to the table as helpfulness to developers?
So HAT is, you can think of HAT as a more extensive exploration of proving or determining that code reflection and Panama are fit for purpose. But I think it has more broader value of exploring how can we leverage GPUs from Java in a library without any magic and internal access to either hotspot or the runtime libraries and so forth. So it's a really strong proof point that we can build technologies in the platform that libraries can use and build applications that maybe people didn't think they could do before. And so one of them is GPU programming, and giving access to Java developers to those GPUs with a decent programming model written in Java. And so if they've got code that takes too long to run on the CPU, often that's only a small part of their program, they could easily switch to this model and change that bit of code and sort of, how should I say, not have to divest in their existing technologies and assets to leverage sort of high-speed computing, as it were. So that's the challenge. Is it's like we want to leverage all of this nice exotic hardware out there just as an ordinary library. We want to prove that out and see where it goes and get people interested, get vendors to slot in to optimize for their runtimes like NVIDIA and Intel and so forth like that. We'll see. We'll grow the community.
Oh, that's nice. One thing for people to know, HAT is also available in the Babylon repo.
That's correct.
So everything that is getting built in Babylon is pretty much transparent over there. Design decisions, ideas are frequently shared by the contributors on the mailing list as well.
Mostly through pull requests, actually, but you can see them fly by. Yes.
True. I know that right now, and probably everybody right now is looking at machine learning, but mostly at AI is the hot topic. I would say to folks listening to us, like you said, just first start with baby steps and then go to complex things. Try Babylon for machine learning and try to contribute to what is already being developed in the examples here. Like enhanced examples, collaborate with the experts here that I'm looking forward to collaborate and share and see your ideas. And then think about how we can benefit to this, expand this into the AI world as well. Paul, anything that you would like to add before we're closing out?
No, I think you've pretty much covered it. Yeah, if you have ideas, please come and tell us what they are if you've tried this out. We'd like to know your experience because, again, we want to ensure these technologies are fit for purpose. And this is our way of doing it. We're not experts in this area. So if experts want to help out, you know what I'd really love to see is an auto-differentiation, a reverse mode auto-differentiation library that then we can hook up to Onyx and we can start doing training.
Here you have it, folks. Another wish list.
So we may be able to get, it's a long way, but we may be able to get a PyTorch-like experience out of this as an experiment. We'll see.
That sounds.
Yeah.
Okay. Thank you, Paul. Thank you, everybody, for watching. Stay tuned. More is coming. And
Okay, and we're back. And I'm here with Dr. Deprecator.
Yeah.
What's up with that?
What's up with that? Okay, so I'm Stuart Marks. I work in the core libraries team in the JDK group at Oracle. I go by Dr. Deprecator because one of the things is I work on deprecating and removing stuff. And, you know, everybody's talking about adding the latest features, and that's all great. We, you know, lots of teams do that, but we also need to take stuff away, and that's not as it's not as fun. So I created Dr. Deprecator to try to liven things up a little bit.
Oh, so you try. Okay, I thought you created like an alternative personality to blame them. Be like,
no,
that's not my fault.
No.
It's his guy's fault.
Yeah, no, but Dr. Deprecator is a surgeon, so we are very careful about how we remove things, and we use a scalpel to remove the old things very carefully.
Yeah. So some of the things that are getting removed or in some contexts disallowed, I already talked to Ron Pressler about another umbrella of integrity by default. That means the SunMISC unsafe memory access methods at the moment are deprecated for removal, but SunMISC unsafe in general is going away. And then there is some things that will still remain in place, but they will be disallowed by default. But we are here now to talk about things that will be really just like hardcore removed, that are currently being deprecated for removal or already deprecated. And I think we brought 4 topics. We're going to do the first ones quick, and then we're going to spend a little bit more time on the last ones. The first one we had is 32-bit ports. Right. So maybe you can talk a little bit about that. I think at the moment in 24, the Windows 32-bit x86. Oh my God.
Yeah, it's not x64 anymore. Yeah. It's x86. Yeah.
Yeah. So that one is gone already.
I think that's gone, and Linux is going to go next. Yeah.
Yeah. Right. So you know, maybe talk a little bit about.
Well, yeah. I mean, there's not much to say. It's like, you know, if you buy a mainstream server machine or some kind of desktop or laptop or something, there's no 32-bit anymore, which is pretty amazing because I remember when 32 bits was the new thing, right? But those are obsolete in the mainstream. Now, I'm sure there are 32-bit computers out there somewhere that people want to run Java on. But actually, one of the practical problems is, you know, when we check in code to the JDK, we have a continuous build and integration system. We run, you know, 8 builds and run thousands of tests and stuff. Finding 32-bit machines to run in that environment is actually really hard.
Oh, I never thought about that. Okay.
Yeah.
True. You need 32-bit hardware to test all that.
Yeah. And so it's all aging out. And so all of that stuff is years old now, and it's hard to keep up to date. And so, so I'm sure somebody somewhere probably wants to have a 32-bit port. But, we're taking it out of the main line because we just can't maintain it.
Yeah.
Or it's not, we could, but it's just too expensive to maintain.
Yeah. Are there also some features that are just implemented like in a rudimentary way in like 32-bit? Wasn't like something like the virtual threads on 32 bits?
Right.
There's like basically like a shift, so they work correctly, but they don't do like the full virtualization thing.
Yeah. I mean, there are some things like that where there's obviously the code generation stuff, but actually switching of virtual threads is something that requires going down fairly low level of the hardware. And so it's like, okay, well, do you really want to maintain a separate 32-bit version of that code? It's all done in native code.
Yeah.
And it's like, well, it's just yet more stuff to maintain.
Yeah, I mean, that's the point, right? Like if resources were infinite, sure, why not? But they aren't. They're very finite.
They aren't
so
infinite.
any minute spent there is not meant elsewhere. Spent elsewhere.
Right.
Okay.
Exactly.
The next thing on the list, I think, is applets.
Yeah.
So why though?
Why remove them, or why are they still around?
Well, maybe the latter. So I already talked to Michael on yesterday's streams. I already said that was actually the first thing I did. I learned after I learned Turbo Pascal in the end of high school. The first Java we did was actually an applet.
Yeah.
I think we did something like people like a restaurant plan, like people sitting on a table, and it was like in a browser. It's very dimly remember. So it was my first Java actually. So why do you take them away?
Yeah.
I have like
yeah, I know. Applets were the big thing in 1996.
Yeah, that's a little later when I learned about them. Yeah, okay.
Yeah. So okay, well, all right. So there's a bunch of reasons. People don't run Java applications in their browsers anymore.
Yeah.
Most of the mainstream browsers do not have the capability to run a JVM as a plugin anymore.
Yeah, that's a matter of like, can they, but won't they do that? Because I think it's like a sandboxing. Like browsers have become much more security focused. Is that not the reason? I thought that was the reason why they were going.
Yeah, I don't know the exact thing, but it's just, applets were very popular for a few years, but then they kind of tailed off. And then after a while, the browser support was removed from them. And so
they might have made the similar decision, right? Like, why maintain this if nobody using it? They also spend time there.
I think so. And I certainly don't blame the browser vendors, but also, the fact is, Java's focus moved away from applet stuff to running, enterprise applications on the server side. So our focus was elsewhere as well.
Yeah.
But surprisingly, it's like, here we are in 2025. Why are applets still around? There is a very long tail of usage of applets still in there, and I actually don't know what.
What do you mean in where?
Oh, I mean in the entire industry.
Oh,
right.
Okay.
Customers in our customer base, right? So I'm not even going to guess about any numbers, but there are. We've been trying to remove applets for a long time. They were actually deprecated. They were initially deprecated not long after JDK 9 when the new deprecation stuff came in, but they weren't deprecated for removal until fairly recently. And then now actually the team is working on removing applets.
Yeah,
I mean, for real.
Yeah, there's an issue on that is so far not targeted yet, but I put it on my slide. So there's like there's the JEP that announces the deprecation for removal. It's at 23 or 24 or something. And then there's a ticket already that says remove it for real.
Yeah, and so it's like, well, how hard it is to remove applets? Well, removing applets itself is not that hard, right? All they have to do is take it out of the API and cut some stuff, just some code cleanup. The real problem is the tests. So the desktop team has a whole bunch of tests that are written essentially using a kind of a homegrown test framework that uses applet.
Okay.
So they have like thousands of tests that they have been slowly working on. Well, I mean, not that they're working slowly, but they have been working the way through them. And there are thousands of tests. There's a lot of tests to work through. They have to, and I'm sure they would have investigated an automated refactoring if they could, but I think that it just hasn't been in the cards. So they just said, okay, let's just do this manually and work through it over the period of a few months, basically rewriting those tests to do some alternate things.
So is there some poor JDK engineer that just like comes to work and just
there's a team,
just moves tests all day long?
This is the client team in the.
I'm joking. Like, how many people are continuously doing this? Because it sounds
4 or 5 people actually.
But all day, every day.
Well, not all. I think
I'm hoping from that note, because that was the job.
Yeah,
because that sounds like terrible work, like week after week of just.
No, I think they're chipping away at it. I mean, this is kind of the thing. You have a big task. You spread it among a few people. Everybody spends an hour a day working on some stuff or something. I don't know exactly how they're working on it, but I think they're working on it over a period of time because there's just a lot of stuff to do. And the thing is about these tests, they're not tests of applet.
Yeah,
they're tests that test other stuff that is still valid functionality. It's just that they use applet in the test framework that they're using. So they have to rewrite all that stuff to extract the stuff away from applet before they can actually remove applet from the JDK.
Yeah.
So
I mean, this occasionally happens. I know of cases, for example, when you one way still to draw stuff is just create a swing 2D canvas, draw stuff in there, and get a PNG out of it. So yeah, I know it's not like apparently unrelated technology can end up being actually a good way to achieve something else.
Yeah.
But then your use of the technology still, and if that technology's original use case is going away, you might end up in a situation where, well, now the thing you're using indirectly also goes away.
Yeah.
Okay, let's go to the two big ones: finalization and the security manager. Pick one.
Okay. Well, we'll start off with finalization first, because we'll save the best for last. Actually, security manager is nice. I like to talk about that. But finalization, we've been working on for a long time. Gosh, where do I start? So
what is finalization?
Okay. All right. Yeah, that's where I should start. Okay. All right. So finalization was a feature that was added. It's been in Java since the very beginning, all the way back to 1.0. And basically, so Java has garbage collector, and the garbage collector normally works behind the scenes, and it basically reclaims the memory consumed by objects that you aren't using anymore. So how does the garbage collector know that you're not using it anymore? Well, basically it walks all the objects and says, oh, if there are no more references pointing to this object, then clearly this object cannot be used. And so we're just going to reclaim the memory and use it for something else. And so in a normal regular Java program, you just never notice that, because if you're not using an object anymore, you don't have a reference to it, so you can't tell whether or not it's gone away.
And the object, technically the object doesn't know that it's not referenced anymore. It doesn't know it's being collected.
Yeah. Okay. So, but there's this problem, which is sometimes we use objects to refer to things outside the JVM, like we have an open file or a socket or something like that. And so in that case, the garbage collector can reclaim the memory, but the garbage collector doesn't know how to close the file.
Yeah.
And so over time, your program will build up with open files and eventually run out of open files, and your system will stop working. So a misguided effort in 1.0 was added prior to 1.0 to deal with this issue, which was finalization, which is, okay, when an object becomes unreachable, when there are no more references to it, instead of just being reclaimed, then the JVM calls a method on it.
Yeah.
Now there's this weird thing, which is when you call a method on it, it's reachable again, because now you have a running thread that has a reference to this object. Now, so that's kind of okay. If you just do some cleanup and then return, you're fine. But there are all kinds of bad things can happen if you plug this back into an object graph and so forth. And there's the JEP, I forget all the JEP numbers. Is JEP 421 that does finalization?
Sure. We just talked about this as well.
Yeah, we got to look at the JEP number.
It's fine.
But anyway, so the JEP explains a bunch of stuff in here. Actually having finalization in the system is kind of dangerous.
Yeah. So one big thing, for example, is that you don't know when that happens, right? Like the garbage collector is intentionally non-deterministic. You don't know when stuff will get garbage collected, so you don't know when the cleanup happens. So you might still run out of file handles,
right? Because
the garbage collector just didn't get around
actually,
to...
that's an excellent point. Thanks for bringing that up. Because so you have a running system. Suppose you use a file, you open a file, use it for a while, and then close it. Okay, so normally you're doing a bunch of tasks. You're opening and closing files constantly. And so suppose you had a system where, because of error handling or just because of programmers write bugs, they somehow forget to close the file. So you might open a file, use it for, might open a file, store the file descriptor in the object, use it for a while, and then let that object become unreachable.
Yeah.
So you still have an open file descriptor in the system, and it will eventually, the garbage collector will come around, notice, call the finalizer.
Yeah.
But meanwhile, you're still opening more files.
Exactly. Yeah.
And at a certain point, the total number of files, might go up and up and up. And in fact, the rate at which you open files might outstrip the rate at which the GC runs the finalizers to close the files. And if that's the case, then you will run out of file descriptors, even though they should be garbage collected. So that's another one of the problems, which is finalization there's no timeliness guarantee on the finalization. And so it's basically a producer-consumer problem. Your producer can outstrip the consumers.
Yeah, so. And so I think the main flaw there is what you said, why it was like a mistake to do that, probably is because garbage collection and resource management it's not entirely unrelated, but pretty much there's a very different concerns. And so meshing these concerns together leads to these results, because the garbage collector wants to be lazy, it wants to be non-deterministic, it wants to say, I know best when to do things, but at the same time, you have the application who has like a vested interest in knowing when things get collected, or rather when things get cleaned up, which in this mechanism was finalization. Right, so people who use Java not for like 2 decades, they're all thinking like, what is it talking about? Why don't you just use a try with resources block, which is exactly where that thing exists.
Right.
Because that's just the better solution in all the cases where it is applicable. Just use try with resources.
Right. Well, yeah, like there's this key caveat you put
where it's
there.
applicable.
All the cases where it's applicable. Yeah. So try with resources. In general, there's a large number of patterns, but not all of them. You open a file or open a socket, use something for a while, and then close it.
Yeah.
But there are times when you want to leave something open and then have, like with a network connection, you leave that open as long as the requests are coming in.
Yeah.
And if requests don't come in for a little while, you park it in a data structure and then wait for some activity to come on it.
Yeah.
So you have to write your program very carefully to say, okay, nothing's come in on that for a minute, so we're just going to close it.
Yeah.
So you have to have something that comes in and does that, and you have to write that code explicitly.
Yeah.
But Finalizer or some other similar GC based API is not going to help you with that. You really have to write that code correctly yourself.
Right. So that explains why finalization is kind of like a dangerous to use feature that can easily be mishandled and doesn't really do what you want to do. And that's why there have been introductions of other mechanisms. We talk about private resources. There's also the cleaner API, which I think we don't have the time to go into, but they're also there for those cases that are left over, basically. So finalization, that explains why finalization isn't needed anymore. But there's more than that, right? Like it creates overhead that garbage collectors need to track. And so it's like a constant maintenance drag and performance drag even.
There are a bunch of semantic problems with finalizers, because one of the fundamental to it is, if an object, you want an object to move through its life cycle in a forward fashion only. So the fact that, oh, this object is now unreachable, then we're going to call a method on it, which effectively makes it reachable again.
Yeah.
So that's a problem. And in fact, it's possible for programs to use that phenomenon to exploit security vulnerabilities.
Yeah, to resurrect objects and
it's probably a little too detailed to get into here, but it's a problem having it in the system. Another problem is that even if you have an object, I mean, it's more of a performance issue. If you have an object that represents an open file, even if suppose you open it, use it for a while, and then close it, great. So it can just be garbage collected now. But if it has a finalizer on it, the GC still has to track it, call the finalizer, and all the finalizer does is say, oh, it's closed already, I don't have to do anything. And that just creates more overhead. And so it would be nice to get rid of it, because the GC guys, have been carrying around this mechanism since day one that they have to support and has to work correctly and stuff.
I think ZGC I think there's a number in the JEP. This is like ZGC's overhead. Like 1% of ZGC's. I mean, overhead is like what ZGC does beyond just the object that it has to maintain. There's like 1% of that. It's just tracking finalization.
Maybe
something that's in the JEP. Yeah. Okay. So that's why finalization. So it's deprecated for removal at the moment, right?
All right. So I'll tell you the current status of that is. I haven't done a survey of how much. I think there are finalizers used in open source projects and so forth, but actually probably the biggest user of finalizers is the JDK itself.
Yeah.
And okay, so here's the thing. So we've been slowly removing. So we don't want to remove finalization until the JDK actually doesn't use it itself. Yeah. Okay. So we're working on removing
fair enough,
those.
I would say.
So of course, the easy ones have already all been removed. Okay.
So you're left with Dr. Deprecator is now left with all the tough.
Yeah.
Tough
well,
fixes.
I mean, it's not like I'm doing all the work myself.
Okay.
But yeah, we have people working on this as well. And it turns out that the most of the finalizers that remain. Well, one is the complicated cases, and the second thing is that these finalizers are all in the desktop area.
Mm-hmm.
And the people who would be involved in helping clean them up are the same ones who are working on removing applets.
You get the point.
Yeah.
Okay.
So there's one of the surprising.
Just remove AWT and swing.
Yeah. Just remove all this stuff.
Just keep killing stuff until we're like no work is left.
Yeah. And so one of the surprising things, maybe it's not so surprising, but I mean it's interesting to experience it. Removing things actually is a lot of work.
Yeah, it's more to do it cleanly.
Yeah. Well, I think part of this whole thing about stewardship proper stewardship of the platform is, yes, we have to do it cleanly.
Yeah, of course. Yeah.
Yeah. And so that takes time and effort, but it does free up, the technology and the resources to move on to bigger and better things in the future.
Yeah. Actually, our next guest, we're going to talk about bigger and better in the future. But now we have unfortunately, for the security manager, we picked maybe the most interesting topic.
Yeah.
We have a minute.
Oh no, we soaked it up already. Okay.
So Stuart, give us the Cliff's Notes on the security manager deprecation. Let's assume people have a rough idea what the security manager does. Maybe it's more important to explain why it needs to go and what the current state is.
Okay. Well, the security manager, it's sort of related to applets, because the fundamental idea of the security manager was, we have a JVM, it has a bunch of code running inside of it. Let's import some code maybe over the network that we don't necessarily trust, or that could be even hostile code, and we import it and run it in the same JVM as all this other code. Well, that sounds pretty dangerous. But the idea is we have the security manager to protect us. So the code that we trust has full privileges. The code that we don't trust has fewer privileges.
Yeah.
And the security manager will manage that. And so this was the big idea around applets, but we already talked about applets, and those are mostly gone. This kind of architecture of loading untrusted code into the JVM was really popular in the late 1990s, and it was built into the JDK in several places. But for the most part, it's not used anymore, and it adds a ton of complexity to the system.
Yeah.
And so all of that stuff has been sitting around in the system, and we've been trying to maintain it, and it's tough. And the fact is, it doesn't do what we want it to do.
It's complicated to use correctly, right?
It's so complicated to use correctly that the number of actual applications that use the stuff correctly is vanishingly small.
Yeah.
And so it's supporting an architecture of downloading code and downloading hostile code into the JVM, which is not something we actually want to do anymore.
Yeah.
If you want to run untrusted code, probably the best way to do that is to create an OS level container and run it inside of that. And then, if something goes wrong, you just kill the container.
Yeah.
And so we don't want to have that in the JVM anymore. But the fact is, we've been dragging along this technology for a couple decades now that is really no longer serving the purpose that it was intended for. And so, we'll take it out.
Yeah, and hence it's going. So the deprecation of security manager is also several multi-step process. I think at current state in JDK 24 is all methods, all the API is still there, but it's all basically NORBs, or it's close to NORBs or transparency as it gets. So really it doesn't do anything. And the command line flags that enable it, they throw errors now. You can't use them anymore. The reason why the API is there is basically so things don't crash too soon, but it will also go away at some point in the future, right? We really fully removed.
A lot of code would have the stylized thing where we say, get the security manager. If it's non-null, then do some security checks.
Yeah.
But if it is null, just do nothing. And so security manager.get or system.get security manager is still there. It returns null. So every code that does that can still call get security manager. It gets a null reference, and it's a no op. It continues to run. So the skeleton of the API and stuff is still there. But if you try to actually instantiate and enable a security manager, you'll get an exception.
Yeah. Okay. Thank you very much, Dr. Deprecator.
Okay.
Almost said Stuart there.
No, watch it.
Thank you very much. And we'll be back after a little mic switch over, and then we're going to talk about strategic development of Java in the present and specifically in the future. I'll see you then. Okay. We just made a good joke and it wasn't live. Anyway.
All right.
So we're here with George Saab. And so when I talk about you to people who are not super into Java, I usually say you can think of him as the CEO of Java. If Java were a company, he'd be the CEO. I think it's worth introducing yourself a little bit more than the other folks because, Brian Goetz and Stuart Marks, those are all those people are on the forefront of development. They give a lot of talks. They're all well known. I mostly just see you once every 2 years on a keynote.
Are you saying nobody knows who I am?
Yes, but nicer.
Okay, that's all.
No, but seriously though, tell all the Java developers who I'm talking to here.
Sure. Yeah. So I'm George Saab, and I am the Senior Vice President for the Java group. I'm also the chair for the OpenJDK Governing Board.
Mm-hmm.
I've been working with Java for a long time. In fact, I've been working on programming languages since the 80s. I've been working on Java since 1996. So I joined actually, I think it was on the same day as Mark Reinhold. What then was called Java Soft.
Mm-hmm.
So, we were run as a little small startup company owned by Sun. And then gradually the group was kind of pulled in as we grew. So I think when I started, there were probably about 30 people. And
Wow.
by the time that I left Sun, I think it was about 5 years later.
Yeah.
We were, I don't know, 1,500 or 1,800 or something. It had grown quite a lot very quickly. But yeah, I kept working on Java. I did a couple of startups in the Bay Area. Turns out 2001 was not really the best time to do that.
For the young audience,
yeah.
a bubble burst back then. Look it up, .com bubble.
Yeah. But then I ended up working for a company called BEA,
Yeah.
Who had acquired this group in Stockholm, Sweden, that was making a JVM. And the big bet there was that Linux and Intel would become big in the data center.
Not bad.
It was a pretty good bet. Some smart folks put that together. So I worked there. I worked with them for a while, and ended up getting acquired by Oracle. And then about a year after that, Oracle acquired Sun. And at that point, the person who was running all of sort of product development in Oracle said, "Hey, wait a minute. We've got a guy who has worked on Java, has worked with the Sun people on Java, and we got this Java group from Sun that we love and want to nurture. Want to make them feel really comfortable." And so he asked me to put the group in Sweden and the Sun Java group together, and the rest is kind of history. So
yeah.
Yeah.
So I talked to Michael Witzet yesterday. You also referenced the Stockholm Java office. They're like doing lots of things, but one thing that they're really pushing forward at the moment is DGC, for example, right?
Absolutely.
So there's a lot of good engineering going on there. Yeah, so let's talk a bit about, so we talked to, well, let's just say, we talked to Dr. Deprecator about what gets removed, but we also talked to Paul Sandoz and Brian Goetz about what gets added. So that's all very language focused, but it's also very specific. It's technical, like, oh, we have this use case, could be small, could be large. So we create this project or this solution. But I guess somebody, and I assume that's probably the buck stops with you there, gets to pick what to work on, though, right? Because there's tons of things one could work on.
Yeah.
So tell us a little bit about the way that the group, under your guidance, like makes these decisions, what to work on, what to pick, what's important.
Yeah, I mean, it's really interesting, and I'm very pleased to say there are just such talented and smart people in the group that I don't sort of go around with an iron fist telling people what to work on. I think we try to work very collaboratively. We have ideas that come from people in the group working on the technology, saying, we think this needs to be better. We think there's an opportunity to do something over here. But we also try to look at the business side of it. And a funny challenge that we see there from time to time is sometimes when you talk with people who are using the technology, they're very acutely aware of the pain points they have today, but they don't necessarily know what was the saying. I think it was Henry Ford that said, if I had asked people the customers what they wanted, they would have said,
a faster horse,
faster horses. Yeah. So like people can tell you they need to go faster, but they can't necessarily see the opportunities for how to bring that about.
Yeah.
And so I think that's one of the things that I feel just amazingly proud of, is the way people in the group are able to ask the right questions and not be satisfied with just, well, let's put a little Band-Aid over here. It's more like, wait a minute, how do we get to the point where we needed a Band-Aid? What could we have done that could have made it so that this is solved actually more in the root area. And so basically we tend to look at the trends. So in hockey, they say skate to where the puck is going, not to where it is.
Yeah.
Right?
Yeah.
Skate to where it's going to be.
I heard that before.
Yeah,
but
exactly.
Maybe from you, like in this context.
Yeah, I think so. Yeah. Well, and a big part of that is we try to look at, trends in hardware. Like what is happening? Like what kind of advances are happening that, 3 or 4 or 5 years from now, people who are writing Java programs will want to take advantage of. And maybe not only for new programs they're writing, maybe it's for the programs they're writing or running today. And but how can we make it so that the JVM is smart and can take advantage of those things? A second thing we look at is programming models or programming paradigms. So just like in many other things, there are trends here. One day everyone's going to do it this way. The next day there's a new thing people are trying out, and everyone's got to do it that way.
I hear object orientation is dead for like the 20th time now.
So I've heard.
Yeah.
But really, it's true that when people do that, there's usually a reason, right?
Yeah.
It's not, it's a trend, but there's also something that's driving that.
Yeah, it's usually like, I think there's often like original reason that pushes it. And when people who adopt this early are in the right place and they talk about how successful it is, and then there's a certain risk that then later there comes a bit of a hype or a trend that beyond that. But there's, as I said, there's probably good reason why people start investing into figuring out a new path of doing things.
Exactly. So, that's one of the things where we try to look at, are there things in Java that, help people do things that way? Or are there not? Are there things we could add? And but I think one of the hard things there is, again, not to just do it as a band-aid, but to sort of think of what is the natural way to do this kind of thing in Java.
Yeah.
And so with that, we see things like adding lambdas so you can do a functional style of programming.
Yeah.
Understanding that people want to actually do things more with data. So data-oriented programming, leading to things like pattern matching.
Yeah.
Right? So I think those are fun. And then very specifically, I mean, those were sort of abstract things with hardware and programming model. There sometimes are very specific things, like there's a particular kind of workload that has come up and everyone's excited about. Everyone wants to do. I could give you a few examples. Blockchain, AI. You can name a bunch.
Blockchain already gone again.
Well, but the thing is, sometimes those come up and then they go away.
Yeah.
But sometimes they come up and they stay, or they change form.
Yeah.
Right. So we talk about AI today, but if you squint at it a little bit, it kind of looks like an evolution of machine learning, which is kind of an evolution of big data. All of these things kind of build on one another. And so even in the cases where, something does go away, often pieces of it remain as value.
Yeah.
Right. And can be useful in other contexts.
Yeah.
And so here again, there are things that we can do in the language, in the platform, at the VM level to support those kinds of advancements. And so I think, that's really what we try to do, is not put in something that's a point solution to one thing that people are screaming for today, but look at it and say, this thing that people want, right? What is it that we can do so that the platform supports that?
Yeah.
And not necessarily as a narrow thing where, this is the only way to do it, but really to say, how can we make it so that, anyone who wants to build something like this could do it with the platform?
Yeah. I think a great example. Sorry, yeah.
Yeah, please.
I think a great example was the section that Ana just did with Paul, which is, well, Java could probably just adopt like some machine learning capabilities directly to the language, something that's usable in that space, and we come up with the solution with the library or whatever.
Yeah.
And then everybody has to use that. But instead, the solution chosen, the solution that Babylon is exploring together with Panama and these other pieces that fit together is, no, let's try to find a way to unlock the power of the community.
Absolutely.
So they are able to build their solutions on this.
Right.
So we don't have a monopoly on like, this is the only solution that can ever be fast and you can build whatever, but it will always be 10 times slower because you don't get access to all the secret VM internals. No, let's create a way where these secret VM internals, this performance, what that's in that specific example that is needed, is exposed to everybody, so they can build their solutions and they can be the competition that we've seen in web servers, unit testing frameworks, IDEs. Everything on Java has like a bunch of battle-tested solutions because they can be built and they can be in competition. And
and I think it's not only about, when you say competition, we're kind of picturing this thing where there are 2 or 3 or 4 alternatives all for the same thing. But something we tend to forget is Java is used in so many places for so many different kinds of things that when people think of a solution like that, they're often thinking about the use cases they care about, right? The customers that they have, and they don't realize that there are hundreds of different things out there that are just like outside of their scope, and sometimes the solutions for those could look very different, right? And so when you have access to those foundational pieces, all those 100 things can be supported.
Yeah, that's a good
you
point,
don't have a one-size-fits-all necessarily.
Yeah, I think that's also interesting, right? Specifically, when it comes to evolving the platform and the language, every individual developer sees a certain slice, right? Like, let's say I do backend development and a little bit of home automation. Somebody else might do game development. It's entirely different, right? So we have different places where Java can be used. And then, of course, if we get a new feature, then maybe my niche, there would be a different local optimum.
Yeah.
But then would hurt everybody else more. So I can guess that's a difficult balancing act there. So what do you see as challenges that Java, or the things that Java is currently adopting to? You also mentioned something like data-oriented programming and AI, for example, but maybe other things or larger things that Java is adopting to other challenges that it's seeing. For example, I heard about in the keynote about the exploration of Java in education. That's an important part. So what are things that you are looking at right now where you think that's where the puck is going?
Yeah. So I do think some of the things around Project Babylon and HAT that I think there's probably some talks at the conference about that.
Yeah. They will be published on the YouTube channel. Subscribe and like, blah, blah, blah.
There we go.
You know the drill.
Exactly. So I think those are very, very exciting. And here, one of the things that I think is really neat is Babylon seems to provide a good sort of at an abstract level of kind of general level, a way of doing code transformation, and taking that and using it specifically for adding really strong distributed GPU support. So that's the kind of thing that I think is very useful. And here again, if you think about that, that's sort of about understanding what kind of hardware patterns are coming, that are going to be available to many more people in the cloud, or even on machines that are close to you. And making it so that you can really take advantage of those, and not take advantage of them by having to go to native code with 20 different solutions for different different architectures, but actually write your algorithm in Java and then have it work.
I remember when I was in uni, which was like, let's just say a long time ago, without going into details, I learned about GPU programming, and I was like, oh, that sounds interesting. So how do I work in Java? And I learned I basically have to write like a big string and dump it through some network. And I was like, okay, I'm not going to do that.
Yeah, super elegant, right?
Yeah, exactly.
Yeah. So I think you also mentioned learning.
Yeah.
That is, I think, definitely one of the things that we're very focused on now, because we realize that there are new generations. There's a different state of the art in terms of accessibility of a platform like Java. We want to make it easy for people to learn, and attractive, right? And a big part of that, I think, is for people to see that they can achieve something and take kind of baby steps to get there, right? I don't have to learn 32 principles of object-oriented programming to write hello world.
Yeah.
Right. I can start with something fairly simple. I can have a sense of accomplishment because I've done that, and then I can go from there. And it's not that we built 2 different versions of the language where you kind of fall off a cliff and you have to be swimming in the shark-infested waters, right? Instead, the idea is you successively can learn new things when they're there because you need them and you understand why you need them. And I think that's a very powerful thing, because rather than being confronted with all of this stuff, it's like, I need to find a way to do that. Oh my gosh, here's one right here, right?
Yeah.
Oh, that makes sense. Now I understand how that works and why it's there. So I think that's exciting. A neat thing though is this idea of making Java more accessible to learners is not just about easier syntax.
Yeah.
Not just about simpler syntax. We've also been doing a lot of stuff. I don't know, you may have had people talking about this already, with things like the Java Platform extension for VS Code.
Okay. Yeah,
right?
we didn't actually. So if you want to talk about
that.
that
I'd
here.
love to mention that. So I think that one's neat, because one of the things that we see happening in a lot of school environments is students don't necessarily get access to administrate their own computer.
Yeah.
They might be running something like a Chromebook or something similar where they've got a web browser, and that's kind of it. And so, some of these in-browser editors have become popular for that reason. VS Code is certainly one of those that's super popular among youth. And so, what we see is that with the extension that we built there, it basically leverages Java-C.
Yeah.
So it's not something where there's a completely different version that has to keep up with all the new language features. When a language feature is in Java-C, then it can be leveraged in this and you can get access to it. So it's a sort of continually improving, continually moving thing, but very, very simple for somebody using VS Code to download and use. So it's the Oracle platform, Java platform extension.
Yeah, I think if you just search for Java extension, I think it's the top one that comes up. Yeah, I think especially Visual Studio Code, I think it was Ron Pressler who, I'm not sure whether it was him though, who explained this to me, because I come from IDEs. To me, Visual Studio Code doesn't have the biggest pool. I already know how to use an IDE, so I use Visual Studio Code's text editor and stuff. So it's good program. It's a good tool. I'm not bashing it. It's just I don't need to use it as an IDE. I already know other IDEs. And then people are of the persuasion, which I somewhat subscribe to as well, real IDEs are just more powerful as well. Should just learn the right tool for the job or the best tool for the job. But I think that overlooks that a student in a learning environment learns so many different things, right? They're learning JavaScript, Java, maybe SQL. They're learning Python at AI stuff. They're learning so many different things. And they cannot be expected to also learn 5 different ecosystems. So to them, figuring out, Visual Studio Code does 4 of those 5, it would expect the 5th, in this case, maybe Java, also to just work in it. And then not to support that would be a serious, downside of Java. So I think it's really good that that's going there. And then also what you said, that steps should be simple. I think it also expands beyond the language, where so many IDEs, so many testing frameworks, so many choices, so many JDKs you can download, so many versions. There's so many options, which is amazing for a complicated production environment, community and ecosystem that solves all these problems with Java. It's not great when you learn, though. It's really nicer when you learn with 5 steps, and for each of them you just know what to do and don't have to figure out what even is a JDK, where do I get it from, and then there's left to run Java-C. And so we're seeing improvements there as well.
And then I think going on from that to the learn.java site, which I'm sure been speaking about?
Well, actually, well, we see it in the keynote. So we streamed the entire keynote yesterday. So my excuse is why I didn't is that. So yeah, Learn.java exists now. So we have Inside Java, Dev Java, Learn Java. Learn Java is very new.
And you know, I think there are a bunch of great resources in dev.java, but those are more targeted towards somebody who maybe is an experienced Java developer, right?
Definitely.
And so the idea with Learn.java is putting something there that are for learners and for educators, right? To try to make it easier for them and give them a good experience, you know, kind of getting to the point where down the road they become an advanced developer who then can use dev.java. And I think another thing that we mentioned in the keynote is a partnership that we've had with the College Board, who make the advanced placement exams. One of which, very popular one, is the Computer Science A exam. That's been around for 20 years, and Java is the language for it. But the version of Java that was used for it up until now was fairly old. I think it was basically Java 8. And so now, nicely, we've done a bunch of work with them to kind of move that forward. But even more importantly was I had a person, Edward Bierman, the executive director for the computer science and for AP at the College Board, who basically said, hey, we get it. Like, computer science is different from many other subjects. A lot of the other subjects where they have AP exams, you know, you put it together, you put together the curriculum, it doesn't change that rapidly.
Basic math is pretty much settled, I would say.
Yeah, or like US history, like, sure, we're building new history every day, but most of what's in the AP exam is, you know, kind of the same, right? And so computer science, though, and something like Java is not, right? And so he said, we get the fact that, you know, when Oracle says, like, you're moving the language forward every 6 months, we took notice. And we're like, okay, we got to find a way to start to look at this. So super exciting, really, really compelling.
Yeah, I think it's really nice. So I'm a Java geek. I learned Java in high school and then university, and then I started working with that because that's what I knew. And then I really fell in love with the language and with its evolution. But to be perfectly honest, that might have happened if I would have learned another language back then. I don't know whether I would have the same positive reaction to it, but
Java was just intrinsically better. That's it, man.
Okay, so twice now you said, I'm sure you've talked about this already when I didn't. So that gives me the impression that maybe I missed a few important things. For a closing paragraph, something else that I might have already or should have already talked about, or are we good?
Wow, I don't know. Like, I don't know what you don't know.
Good point. Yes.
No, but the thing is, that's always the case. And so this is one of the reasons why, when we're thinking about evolving Java, we try to say, like, what can we do to make the things that can be predictable as possible?
Yeah.
So knowing when there are going to be releases coming out, knowing where you go to find out about the features in those releases, knowing that you can download, you know, builds of those before they come out and try them out on your code and tell us about what you see, right? This is about making a, you know, predictable backplane, so where, you know, when you're running Java, we've got you. You're going to be good, right?
Yeah.
But that then means that we can focus on the really interesting and compelling part, which is, what is the innovation, right?
Yeah.
And so also understanding, where do I go to look at that and understand it, knowing about the projects that are stewarded by people from Oracle and others in OpenJDK. And so you can learn about, like, where is the language going, you know, in a year, 2 years, 4 years, and how can I take part if I want to and contribute to that.
Right. So I see your role then is a lot of this building that substrate, right? Where all the other folks can then build on and build amazing things.
Exactly.
I want to thank you for that, George, because it's clearly working well, at least from my perspective.
Thanks. I appreciate it.
So we're going to have another live stream tomorrow, California morning, I think, at about 8, I want to guess. Yes, I'm getting a thumbs up at 8. So it'll be in about 16 hours if you're elsewhere in the world. We're going to talk about, Billy is going to be here. I'm pointing off camera. Billy's going to be here as your host, and we're going to see the community keynote. That's been a big chunk of that. So we're going to have a lot of good things there. And there, I hope we'll see you then, and have a good one. Bye.